Good afternoon, everyone. My name is Shravan Kumar from Delsoft Technologies, New Delhi. Welcome all to this 3 days online FDP session on networking simulation using NetSim software. So today is our second day of the FDP. So we'll have an introduction of wireless network and MANET. Then we'll design and analyze a MANET scenario using NetSim software. And we will implement a sinkhole attack, that is very severe attack in MANET, through custom code and how we can implement it in NetSim. So your mics are muted. So if you have any questions, you can write in your question box. We'll discuss it after presentation. So this is NetSim version 9.1. So the attendees who were not present yesterday, so I'll just give you a brief about the NetSim software over these technology metrics. So the whole software NetSim is divided into these 8 components only. So first is internetworks. It is having Ethernet, wireless LAN, routing, TCP, UDP. Then component 2 is having legacy network over Aloha, CSMA, CD, token ring. Component 3 is having BGP network, border gateway protocol. And component 4 is having advanced wireless network, that is having mobile ad hoc network, vehicular ad hoc network, and WiMAX. And 5 is having cellular network, GSM and CDMA. 6 is having IoT, Internet of Things, wireless sensor network, and ZigBee. Then component 7 is having cognitive radio network, and 8 is having long-term evolution or long-term advance. So the whole NetSim software is divided into these 8 components only. So yesterday we have studied about internetworks, but today we will study about the MANET mobile ad hoc network and its common attacks that occur in the network scenarios. So NetSim has 2 versions. One is academic and one is research. So in academic version, you can design and analyze all these technologies with these components, and you can see your result and analyze on various aspects. But in standard version, that is the research version, so you can have the source code of these technologies and their protocols. So you can edit those protocols and you can create your own protocol also. So this software has interface with Microsoft Visual Studio. So any code you want to edit, you have to go to Visual Studio environment and you can edit any source code there. And then you can link it with NetSim by calling that DLL extension of that file. So that is the procedure to work. So now we'll go to our today's topic, that is wireless network or mobile ad hoc network. So first is wireless network. Wireless network can be divided into 2 parts. One is infrastructure based network, which consists of our traditional cellular system having base station infrastructure, and wireless LAN using infrared or radio links, though these are very flexible within the reception area, but they have low bandwidth compared to wired networks. Then second is ad hoc networks, which are very useful when infrastructure is not available or in very impractical situation. These networks can be used. It can be used for military applications, rescue operations, home networking, and many other areas are there. We will cover in application part. Then this is the pictorial view of comparing infrastructure and ad hoc network, where in infrastructure network we can see the devices communicate among them using an access point connected through a wired LAN, whereas in ad hoc network, devices communicate among them using a set of protocols like DSR, AODV, OLSR, and ZRP protocol. So this is the basic difference, architecture difference between ad hoc network and infrastructure network. Then this is the architecture of ad hoc network, where devices communicate directly within a certain range in their basic service set. In the picture, STA is given, which is a station terminal having access mechanism to the wireless medium, and IBSS, independent basic service set, are a group of stations using the same radio frequency. So this is about architecture of ad hoc networks. Now, why ad hoc network? So as we know, in an infrastructure network, we require number of devices to communicate in a certain range, which is not possible in those areas where wireless communication is highly required, like disaster area, war zone, forest areas, etc. So then we prefer ad hoc networks where we do not need backbone infrastructure support and we communicate with wireless devices having a set of protocols like DSR, AODV, etc. as it is easily deployable and useful in such areas where infrastructure is not available. So we prefer ad hoc networks over infrastructure network in these areas. So these are the various applications in different areas of MANET. So first is in civilian environment where it can be used in taxi cab networks, then meeting rooms, sports stadiums, boats, small aircraft network. Then in emergency operation it is used in search and rescue operations, then firefighting operations or policing operations. Then in personal area network, cell phone, laptop, earphone, wristwatches, these are the PAN networks where it can be used. Then military environments, it is used in ground warfare scenarios where infrastructure network is not possible. Though ad hoc network is highly beneficial in wireless communication, it has some limitation in these three aspects. First is limitation of wireless network, then limitation imposed by mobility, and limitation of mobile hardware. So limitation due to wireless network is, in a wireless network, we know there might be some packet loss due to transmission errors, then there might be variable capacity links, then frequent connection and disconnection of the devices would be there, then bandwidths would be limited, and it's a broadcast nature of communication, so some devices uh, that do not receive the signal. So these are the limitation due to wireless network. Then imposed by mobility. As the devices are mobile in nature, they are moving with some velocity. So they are changing the topology and routes. Then lack of mobility awareness by system and application is there. So, and in limitation of mobile hardware, as these devices are mobile, so they have some sort of power, some battery life is there. So they are having the limited capacities to work in a scenario. So that also is a major challenge in the ad hoc network. So these challenges leads to the research we do in our curriculum or our research. So we have to improve this limitation to work MANET uh, to some other extent. So this is about sinkhole attack. So as in MANET, so first I will go to the software and show you how a MANET scenario works. Then we will go to a sinkhole attack and see its functions. So let's go to the software first and then we study about sinkhole attack. So in NetSim scenario, in a MANET, we have to open new and you have to go to advanced wireless network and MANET. So as the MANET has the wireless devices only, so all other nodes are disabled. So we can choose this wireless node and drag and drop in the environment. So these devices we have put there. Now we can communicate between any node. So first we go to the properties of mobile ad hoc network devices. So first is having the global properties, that is device name, device type, its location, then Wireshark can be enabled or disabled. Then mobility model is there, four types of mobility model: random walk, random waypoint, group mobility, file-based mobility. So if you select random walk, you have to give the velocity and it will move according to the speed of this velocity of the device. So we have to click on transport layer where UDP protocol is selected by default, and segment size 1472 is by default given. We can change it. Also, I have told yesterday about this information tab. If you want to study about the parameters given here, you can click on the I tabs or information tabs and you can see the details about these parameters. Okay. Then in network layer, we can select the routing protocol, that is DSR, UDV, ZRP and OLSR. Okay, so we can select any of the protocol and acknowledgement type is given there, network layer acknowledgement and link layer acknowledgement. Then interface wireless, we have IPv4 protocol, then IP addresses, subnet mask, ARP retry interval, retry limit, then you can enable or disable this IEEE 802.11e and RTS threshold, rate adaptation algorithm we can select. Okay, this is the standard for physical layer of this 802.11 ABG and AC. Then CCM mode, bandwidth, frequency band, and ED threshold, standard channels. Then we can select the power source from here, either it can be mainline or battery. Okay, so which is the very main parameters of power source in wireless devices. So we can select accept it for default. So likewise, all other devices are also there. We can select. Let's say we can select the mobility model, same for that. Okay. So now we can give now by putting the application tab here, we can choose the application type to send on these devices. So let's say we are sending from 1 to 6 a CBR packet from 1 to 6. This packet size, interval time, same. We just accept it and we can run the simulation from here. So now we can simulate and see the result. So I have a ready-made experiment by showing some results where we are considering some parameters. I'll just show you that experiment. That was to demonstrate how we can change anything in the MANET devices, wireless devices. Now I'll show you an experiment where I have chosen these 6 devices and align them in these 2 parallel lines, and I'm sending different applications on different nodes. So what I'm doing here is, first I'm sending 3 applications. One is custom application from 1 to 4. From 1 to 4, then second application is 2 to 3, that is 2 to 3, then 5 to 6. Third one is for 5 to 6. So I'm sending these 3 applications over these devices. And what other things I have to consider here is this is the experiment to analyze when we increase the speed of the device, when we increase the velocity of a device, how your throughput affects. So first I am giving the 10 meter per second here to all the devices. All the devices are having the random walk mobility model and velocity 10 meter per second. All the devices have the same parameters. All the devices have same velocity and same mobility model. Okay. So now when we run the simulation, now it has been simulated, and in application metrics you can see the throughput of the devices. Okay, so we have added the 3 applications. So for overall throughput we have to add this throughput. Okay, so we just return these data somewhere else. So we are considering that 10 meter per second have some values of throughput here, and we can see the animation part also, where we can see the mobility, how devices are moving, and our application is sending from source to destination. So here in this panel we can see the source name, destination name, packet info, status, and the simulation timing. So here we can see some error is there. So if the packet is sent, it is show the successful status. If it is not sent, we show error. You can increase the animation speed to see the animation faster, and you can increase the simulation timing also to see whether your mobile devices are moving or not. So you can see at this time of instant your devices have moved somewhere and their location is changed now. So the packet status of the packet sending is changing now. Some is successful and some is having the errors. So as the location of the devices changes, the status of sending the packets and receiving the packet is also changing. So as the devices are moving, so there might be some more prone to error because there might be some loss of data among them. So this is having the 10 meter per second velocity and they are moving on this speed. So now we will change the speed from 10 to 30 meter per second and see what is affecting our throughput. So we just closing it. And we'll open the second scenario where we have changed the speed to 30 meter per second. Now speed is 30 meter per second for all the devices. And mobility model is also same, random walk. Okay. Now the application is same. We are sending the same packets on the same devices, Now we can run. So as it is taking time, we'll just see two scenarios and I'll show you the result. We can enable the Wireshark also so that it can capture the packets on any node. So it will start with the simulation and run along with the simulation. So currently we have disabled here just to see our result. Okay, now it is simulated now. We can see the application. So now we can see some decrease in the output is there. Okay, so when we add this and we consider that earlier throughput, so this throughput is decreased somehow. So we can see the animation first. So as the devices now move with the higher speed, so there might be loss of data much more than the earlier case. So that's why we can get our throughput somehow less in a real scenario. So for increasing the speed, we can select this, and also we can increase our simulation timing to see the devices moving. So as the devices are moving fastly, so the success is rate of sending the data is now less. And error is also keep on coming. So as the position of the devices are changing, and they are very much distant from their actual positions, so there might be decrease in the throughput. So as again we can increase the speed of the devices to some other values, let's say 50 or 60. So that also decrease in the throughput. So here we have analyzed that as we increase the speed of the devices, the throughput decreases. So we can see here. So I've just plotted these values on Excel in 10, 30, and 50 meter per second velocity, and throughput is this. So when we plot in a graph, we can see the throughput is decreasing with the increase in velocity. So as we increase our velocity, the throughput falls. Okay, so we can do some more experiment where we can constant the speed of the devices, and we increase the device number of devices. So with the increase in density, how it affects the throughput, that we can also analyze. Or we can change some other parameters of uh, the packet size, interarrival timing. So all other parameters also we can change, and we can see how our throughput affects with these parameters. So that's the benefit of these kind of simulators, that we have the option to change anything in the parameters, and we can see the result accordingly. So that's the main benefit of the simulators, that in a single environment we can change many parameters and see the different results. So we have seen the MANET scenario, how it works. Now we will go to the presentation now and see the sinkhole attack, which is a very common problem that occurs in MANET. So as we know, it is a very severe attack in mobile ad hoc network, in which a malicious node creates a wrong route to pretend itself to be a destination node and receive the whole packet, whole traffic, without further transferring to the actual destination node. So after receiving the whole traffic or data, there is a threat of modifying or vanishing the whole information available in data traffic. So it mainly affects the performance of DSR protocol. So in DSR, source sends route request or RREQ packet before sending the whole traffic. So on receiving this route request, it sends the route reply to the source to send the route information and then sending the traffic. But it is possible to send route reply by some other intermediate nodes if they have the route information. So the malicious node take this benefit and send route reply to create a non-existing or fake route. So source node sends route request to this malicious node and receives route reply from it. Then source find it most appropriate path to send all the information to this malicious node, which pretends itself to actual destination node. So all the traffic now goes to the malicious node, and it can further modify the packet information or completely vanish it from the network. So now for implementing sinkhole attack in NetSim, we have to add a file called malicious.c to the DSR project, which is having below functions. So first function here is DSR malicious node function. So this function is to identify whether a node is malicious or not. It finds the node's malicious behavior, identify it if it is malicious. Second function is malicious route add to cache. This function is to add a fake route in the network to establish connection from the source. Then third function is malicious process source route option. This function is to drop all the received packets from the source, instead forwarding it to the destination. So these three functions we have to add in malicious.c, and the further we have to add the malicious.c file into the DSR project. Now here we can understand the scenario where node 1 is the source and node 6 is the destination. This is the source, this is your destination, and these are the other devices present in the scenario where node 2 is identified as malicious node. So node 1 is sending traffic to node 6, which is our actual destination, but this second node, which is malicious, sends fault information or root reply to node 1 so as to pretend itself to be the actual destination, and it receives all the traffic from source 1. So rather sending the packet from 1 to 6, it sends all the traffic to the second, from 1 to second node. So this is called sinkhole attack in MANET. So now, before going to the intrusion detection system, IDS, let's go to the software and see how we can implement a sinkhole attack in MANET, and further how we can implement it. So we have already made project of sinkhole attack, so which is having the simulation netsim.solution file. So we just have to click on this. So it will open into the Visual Studio. So this is a DSR project where we have added a malicious.c file here. Malicious.c file here, and we have opened it. Okay, so this is your malicious.c file. So all these functions are there, which I have shown you in the presentation. Malicious node, then malicious root 82kh, then malicious process source root options. These are the main functions. So we have to identify which node we have to make malicious. Okay, so here we have identified node 2 is malicious. So we have to, if you want to edit anything in this program, you can edit it, and you have to click on the DSR project and click rebuild. Okay, so if we rebuild it, it will create libdsr.c file, .dll file in this DLL folder. So we just have to copy it and paste it into the bin folder of the installation directory of NetSim. So those who were not present yesterday, I just brief you about this custom code implementation, that if you want to change anything in the existing protocol, you have to edit anything into the Visual Studio. All your project would be open in Visual Studio. You have to go to the installation directory of NetSim. This is the installation directory where these files are present. So in the bin folder, all the protocols related to NetSim are present here. All the protocols are there. Okay. So when we call any of the functions or protocol, this NetSim understand this DLL extension only. So it call those functions and implement it. So here also, and for opening all those protocols in Visual Studio, you have to go to the SRC folder and simulation copy. We have made it a similar copy of simulation just to save our existing DLLs. So we have to open this netsim.sln file, and it will open the Visual Studio directly as it is interfaced with it. So all the protocols available in NetSim will be open here in the Visual Studio environment. So we can edit anything and we can create the DLL extension and interface with NetSim. So we have just copied that DLL, and we go to now the bin folder of NetSim, and we paste DLL extension here. So we just replace a file which is already present. So libdsr.dll is here. This is our edited DLL. So we have made this libdsr default DLL as we want to save our original DLL. So we just rename it to default, and this is our edited DLL now. So if we call now the libdsr.dll function, it will call our edited DLL. So this is for Sinkhole implementation. So now we can open a scenario. We have implemented our edited DLL. We can now open a scenario of MANET where we have implemented the Sinkhole attack. Okay. So these are 6 nodes where this is same as we seen in the scenario. We are having 6 nodes. We are sending the packet from 1 to 6. CBR application we are sending. And now we will simulate it. So in properties we are having CBR, source ID 1 to destination ID 6. So we just accept it, and now we will simulate. So when we click OK, it will show you that detected a change in libdsr.dll. So if you press any key, it will simulate further. So in application matrix, we can see we have implemented a CBR application from 1 to 6, which is our destination ID. But we can see here packet transmitted is 499 and packet received is 0. Our throughput is 0 now because we have implemented a sinkhole attack here in MANET. So rather sending the packets to the actual destination, the source has sent all the traffic to the malicious node. So that we can see through packet animation. So let's play the animation. So it is sending all the DSR requests to the nodes. So here when it will get the root reply, it will start sending the packet. So we can see here, so node 1 is transmitting to the node 2, but it is not transferring the data to further to the node 6. So as we have made this node 2 as malicious node, it is now pretending itself to be a destination node. So it is accepting all the traffic, and node 1 is sending all the traffic to this malicious node. So rather sending packet from 1 to 6, it is sending the 1 to 2. So we can increase our animation speed and see the animation faster. So our sinkhole implementation, we can say, is working now, and this node 2 is malicious and receiving all the packets from node 1. Okay. So sinkhole implementation is over. Now again we can go to the presentation and see about intrusion detection system. So IDS monitors, or intrusion detection system monitors, the network for malicious activities And once abnormal behavior is sensed, it takes preventive measures to recover from the attack, and it keeps track of the network in future also to avoid such incidents. So for implementing IDS in NetSim, we have to add malicious.c file. These two major functionalities to the DSR project. So first is watchdog and second is path reader. So in watchdog, a watchdog timer is added to each node in the network. So when the timer starts, when a packet is sent, so once packet is forwarded to the other hop within the watchdog time derivation and the next hop is malicious, then it need not forward the packet as per the sinkhole attack implemented. Okay, so it adds a watchdog timer which see if it is a malicious node, it will not send packet further. So counter is used to keep track of the number of time watchdog timer expires. So once the timer the counter reaches the failure threshold, the current node marks the next hop as malicious and send it for blacklisting. Then a path rater, it adds malicious node to the blacklist and it validates routes by verifying the route reply. Then it discards the route reply if blacklisted nodes are present in it. So these are the main functions of these two functionalities. Now for implementing IDS in NetSim, we have to add these two files watchdog.c and pathrater.c in IDS project. So in watchdog.c has two major functions. So one is add watchdog timer, which adds a watchdog timer to each node in the network, and watchdog timer execute, which checks if the packet is sent before timer expiry and check if failure threshold is reached. Then pathrater.c file is added, which has also two main functions: add to blacklist, which adds malicious node to blacklist of the current device, and it verifies the route reply with this function and check if the IP address in the route reply contains the IP address of any blacklisted node. So this is simulation of IDS in NetSim. So now we have a comparison of metrics, network performance. So we can see in the comparison throughput, when we have normal working, we are having some values of throughput. But if we are having any attack, sinkhole or any other attack, our throughput is almost zero. But if we are implementing intrusion detection system, we are getting some values. So it improves our throughput when we implement an IDS. Also in comparison of application delay, we can see we are having values when we are having normal condition. Then in attack condition, we are having almost zero values of delays. Then with implementation of IDS, we are getting some values. These are the main research areas in MANET that we can implement with NetSim: routing protocols, location-based, power-aware, quality of service in ad hoc networks, intrusion detection, performance analysis, and vehicular ad hoc networks. So currently I don't have the codes for IDS, so I'll just show you uh, within by showing you with this video. So I'll show you this video where you can see how IDS is implemented and how it
We
works.
see that node 1 sends DSR root request to which node 2 replies the fastest. Hence node 1 forwards all the packets to node 2 to be forwarded to the destination. Node 2, being the malicious node, doesn't forward these packets to the destination node. Node 1 runs a watchdog timer of 2 seconds and finds that packets are not getting forwarded from node 2 within that duration. Once the count of packets reaches the failure threshold, the node is detected as malicious node and any route from that node is deleted from the root cache. After that, node 1 sends packets to node 3, which in turn forwards the packets to the destination node. Thus, the malicious node is detected by the intrusion detection system and packets now traverse in the route from node 1 to node 3 to node 4 to node 5.
So we have seen that how the IDS implements and how it will work. Apart from other matrices, we have the DSR matrix in it, where we can see the root request, root reply sent, root reply forwarded, all the details regarding the root request and root reply we can get from here. So also I've shown yesterday that we are having the user manual, source code help, and experimental manual, where we can study about these experiments. We have around 22 experiments with different technologies. You can click on any of the experiment and see about these theoretical parts, its mathematical part, its procedure, how we can work on it. We have the procedures with the screenshot and the values also. We can fill it and simulate it. What we have to analyze, that is also given there. And how we can implement it. All these things are given in the experimental manual. So this is about mobile ad hoc network and its sinkhole attack and implementation of IDS. So now I'm done with my presentation. If you have any query, you can ask me by writing your question in the text box, or further if you have any query in future, you can mail your query through this email ID.